Okay, so here they say, which statement is true about the relation shown on the graph below? Now, when they say relation shown on the graph, they're talking about this circle. That circle is a relationship. It could be a function, it might not, and it's the one though that's drawn on this graph. So we're trying to pick a statement that represents what we're finding here. So the first one says, it is a function because there exists one x-coordinate for each y-coordinate. Well, it's not a function, in fact, because if you were to draw a vertical line, let's say here, right? Well, here, let's say this point is 1, 2, 3, 4, and then, I don't know, -1, right? Let me fix the pen tool. Maybe it's 4, -1/2, I'm not sure, I can't tell. Here, this point is also 4, but a different y value. 1, 2, 3, 4, 5, 6, 7. Check that again. 1, 2, 3, 4, 5, 6, 7. So notice what happens is we have here one input of 4 with two separate outputs. That's not a function. So this one can't be correct. And this one can't as well. And it says, and if you look at the difference here, it says there is this one y coordinate for each x coordinate. And well, in that case, right, this doesn't apply because we're looking at something that's not a function. So let's keep going. The third one, it is not a function because there are multiple y values for each given x value. Well, that's what I would circle here because that's exactly what's happening. We have multiple y values for a single x value. In other words, multiple range values for a single domain value, and that's not what a function is. The reverse could be true, and that would be okay, and in fact would not mean it's not a function. If there are multiple x values for a given y value, that's fine. You could have, right, you could have, let's say, I don't know, if the y value is here, right, and look at this point as well. What's that point? It's 4, 5, 6, 7, 8, 8, 3, and then here, 0, 3. So here we have two input values, 0 and 8, and they both lead to 3. That's okay, right? That doesn't mean it's not a function. So if we look back to 1 and 2, it turns out, of course, that the first one, 1, is not relevant for whether or not it would be a function. Whether or not there exists one x-coordinate for each y-coordinate, which there is not, wouldn't actually determine whether it's a function or not. It's the second choice that would. If the function has exactly one y-coordinate for each x-coordinate, then what you have is a function. If you have multiple y-coordinates for each x value, then of course it's not a function. Alright, I hope this helped a little bit.